Hey, what's up, Ziguanas? This is day 25 of the 30 days of Zig coding challenge. Join me one more time, 25th time in a row, as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new language. The name of the language is Zig. My name is Dusan. Welcome to Zignited. Yeah, I'm kind of like tired of saying the same thing all the time, but yeah, 25 days in a row, the same intro, but yeah, there is no let's say a very different way to greet someone and to explain what the thing is about. So yeah, I guess this is how it is. So day 25 already. Time really flies when you're having fun. Let me open up the docs and to start with today's topic, which is illegal behavior in Zig, of course. So yeah, one announcement before I continue. So because today is day 25, tomorrow I will do special edition and day 26. So the special edition will be the summary again of the things that I went through in the last 5 days and a bit more. So I will do some practical coding, probably 4 inline game, something like that. We'll see. That's the general idea. And for you guys who are maybe for the first time here, so the thing is I stream live my Zig learning experience. I haven't had any experience 25 days ago, so this is literally like my 25th day that I am trying to do something in Zig. I've never seen a single line of Zig code before, and I do have a lot of code experience both as a developer and a mentor tutor. So I just wanted to document the process and show how I would approach learning a new language. And this is, of course, a bit different than how you normally would. So normally you don't stream learning the language. So that's why I had to adapt a little bit. So on one hand, I'm handicapped because I cannot do some boring things in stream, so nobody would watch if I just like 3 hours stream and just like reading the docs and rereading the same parts over and over again and practicing the same things over and over again, which is usually how you would do it. So I am handicapped in this way because I can only do a more superficial analysis than normally I would. So that's, let's say, what is the bad part of this streaming live and how I have a worse situation than normal. But on the other hand, I have a better, let's say, something that you usually don't have when you learn on your own, and that's the people who are joining the chat and watching the streams live, because a lot of people who have experience with Zig help me. They explain some concepts, so I communicate live, and then I learn quicker some things that are important that I wouldn't find in docs in the other way. And that is, let's say, the pro when you're doing streaming. It's again, it's not a normal thing. So normally you don't have, if you learn on your own, of course, if you learn in some company, if you have some mentor to teach you something, to help you learn something specific, then it's kind of similar thing. So you have people that are ahead of you in that part, in that topic, and they can help you out. So this is something like a combination of good and bad sides of streaming and trying to learn while streaming. That being said, let's jump into illegal behavior in Zig. So let's see what they say. Many operations in Zig trigger what is known as illegal behavior, IB. If illegal behavior is detected at compile time, Zig emits a compile error and refuses to continue. Otherwise, when illegal behavior is not caught at compile time, it falls into one of the 2 categories. Okay, some illegal behavior is safety checked. This means that the compiler will insert safety checks anywhere that the illegal behavior may occur at runtime to determine whether it is about to happen. If it is, the safety check fails, which triggers a panic. All other illegal behavior is unchecked, meaning the compiler is unable to insert safety checks for it. If unchecked illegal behavior is invoked at runtime, anything can happen. Usually that will be some kind of crash, but the optimizer is free to make unchecked illegal behavior do anything, such as calling arbitrary functions or clubbering arbitrary data. This is similar to the concept of undefined behavior in some other languages. Note that unchecked illegal behavior still always results in a compile error if evaluated at comp time, because the Zig compiler is able to perform more sophisticated checks at compile time than at runtime. Yeah, which makes sense. Most illegal behavior is safety checked. However, to facilitate optimizations, safety checks are disabled by default in the release fast and release small optimization modes. Safety checks can also be enabled or disabled on a peer block basis, overriding the default for the current optimization mode using set runtime safety built-in function. When safety checks are disabled, safety checked illegal behavior behaves like unchecked illegal behavior. That is, any behavior may result from invoking it. Okay. When a safety check falls, Zig's default panic handler crashes with a stack trace like this. Okay, so this is a simple example where you have unreachable, which will crash, and we will get some error like this one, reached unreachable code. Okay, so this is the very first topic that they address, reaching unreachable code, and they have two options, right, at compile time and at runtime. So the first thing they do is they have this function, they call it assert, which takes one parameter, okay, which is a boolean, and returns void, so nothing. And then they test if not okay. So like this, it's not okay, right? So it would be true. Then this is triggered. And then because it's comp time, you will have this reached unreachable code, because here during the comp time code block, which is explicitly noted that it should run in comp time, this is going to be false, so it will reach into this unreachable code, and it makes sense that this is going to happen. But at runtime, so the difference here is that you don't have this comp time code block, which then is compiled and evaluated during the comp time. Here you have the regular main function, which calls this standard library debug assert method instead of this one. So this is a custom made. This is the built-in one, and they have false as a parameter, and this is going to cause the unreachable during the runtime, right? So panic reached unreachable code, and here again panic reached unreachable code, but the difference is the one is during the runtime and the other one is during the compile time. Let me just see. I just want to see how the messages are different. They're the same basically. Okay, and let's see what else they say. Nothing here. But then let's see the next one. Index out of bounds at compile time. So during the comp time, they have this example. They create a constant array, which is of type U8, has 5 elements, and they take the string literal with these 5 characters, and then they dereference it here. And then they have another const, which takes this array. It takes only the last element. So in this case, the last element is actually here outside. So strings are 0 terminated, so it should be 0, but this doesn't count as a regular element. So this is basically reaching outside of the bound. So looking for the 6th character, which is not there. then they dump it into the underscore variable, the empty one. And then, of course, they got this out of bounds, index out of bounds error, index 5 outside area of length 5. Hi, Enlighten Hub. Hi, welcome. Hi, Mehran. Welcome. How do you learn a new language from where start? Like, where's all the resources, and also how do you start? Okay, so depending how popular the language is and how new the language is. In case of Zig is pretty new, so it's not made last year, so it's already there a few years. But it's not also, let's say, like Python, which is 30 years almost old language. So in case of Python, you have many resources, and especially because it's the most popular language in the world. So you have many YouTube tutorials, you have many other kinds of tutorials, books, like dozens and dozens of books and so on. In this case, because Zig is not that popular as Python, not that old as Python, so it's like 6 or 7 times younger than Python, approximately, so we can check the dates exactly. That means that you don't have that many resources. And Zig is like a good one because you can find some more exotic languages which you literally don't have where to learn from. So your only way of learning those kind of languages would be to read the docs and then to experiment yourself. But this requires you to have at least some previous experience in programming. It doesn't require, but it will be much harder if you don't have any previous coding experience. So what am I doing here online during the live streams? You can check from literally from the first day. I haven't had any experience with Zig, so 0 Zig experience. And I wanted to start from the docs because I wanted to see first the official docs and to experiment some things myself, because I don't like just watching the tutorial, and it wouldn't be also interesting to stream how I watch other videos. So that wouldn't be so interesting. So I decided to go through the docs and then take their examples and run them. So because now I'm already reaching the end of the docs, so I went, this is day 25, so I'm almost at the end of the docs. So that's why I don't run that much of a code anymore, because first of all, there are very specific things that I'm going through now. So they're not the core concepts of the language. There are some, I mean, you can say it's a core concept, some of these, but they are not something that you can play with. So the examples that they provide are straightforward and it's easy to understand. But before, let's say the first 15, 20 days, I literally copy-pasted the code from here, the examples, and tried to break the code and to see that I changed something, because I didn't know anything about the language. So I had to experiment and to see how the language runs if I do something different, and watch the errors and try to figure out how it works. Because the docs are not only Zig, but in general, documentation is not meant to provide you all the things you need to learn the language. They just like compress the topics and they give you some few examples, and then it's up to you to figure out on your own how the language works. If you want some more deeper knowledge and to have some, let's say, better, not better, but let's say different and larger resource to learn from, you need something like a book or some extended tutorial to help you understand things. But you don't have that many books. I tried to research, and you don't have, like, there are 2 Zig books that there are several more, but they are just like the AI copycats of some other languages. They're not actually about the Zig. So if you take a look into these books, you will see that the authors basically copy-pasted something from AI, and they don't know Zig, so they just like pasted and printed the book on published the book on Amazon, and it's actually not about Zig. So you don't have that many resources for Zig. And like I said, Zig is even like better than most of younger languages, because they literally don't have even what Zig has. So you have very limited resources for Zig specifically, but it's better than most other languages that are newer and younger. So that's pretty much how you can start a new language from scratch. It depends on the language and how long is it on the market. So with Python, JavaScript, Java, it's very easy because you have billion of people, like not billion of course, but let's say hundreds of thousands, if not million people using it. So you can find even tutor that will help you, because most of the people know Python and JavaScript, so it's easier. And try finding a tutor for Zig, for example. It will probably be very hard to do that. So all depends which language you want to learn and how much experience you have. But my best advice is to do the practical thing. So not only read stuff, but try to implement as much as you can as you go. So try to see how the code works, try to change things, try to, for example, if I were to test with, to play with this code, I would try to see if I change the type maybe, or do something like that. So see what will happen if you don't know. So now I already know these basic things about Zig, so I don't need to do that. But this is something that, like, what you should do. And every time you go through a topic, let's say if you spend 1 hour researching strings, for example, in whichever language, doesn't matter. So you watch the tutorial that is 1 hour long, or you read the docs for 1 hour, something like that, then you should spend at least, let's say, 2 or 3 hours on your own. You just try to do something with strings on your own. This is the best way to learn. If you just watch tutorials and read the docs and don't test the code yourself, don't build anything yourself, you will not learn anything. And you can see, for example, how I here, if you if you see my videos from the beginning, for the first 10 days, I went through the docs and I did practically test immediately something, like change the code, these small pieces of code to test to see how it works. And then after 10 days, I did first a summary, special edition of the stream, where I wanted to create a tic-tac-toe game in Zig. And then this is actually when I learned the most, when I did a longer coding session. It was like 1 hour and something maybe, that first one, and I ended up making 3+1. I say +1 because the last one was actually Robert, who is regular here on streams. So Robert has more experience with Zig, and Robert did kind of like, let's say, a code review, a special code review to demonstrate some features of Zig so that we can go through it. So I did a special edition yesterday going through his code, and it was using, so Robert was using in the code some features to show how you can do some things in Zig. So this is excellent for learning purposes. So this is in general advice. And if I were to say, so like I mentioned before, I have about 15 years of code teaching experience. And if I could, let's say, give one advice to my students, so you're not my student, but I'm just like generally saying, if someone hired me to help them learn any language that I can teach them, if you tell me like one advice, the most important advice that you can give to anyone is what I said like a few minutes ago, just like practice. Dedicate the time. If you have one topic, if you read about it, or if you watch the tutorials about that topic of that language for 1 hour, then spend 2-3 hours practicing things on that topic. That's the most important. And the more you move forward to more advanced things of the language, you need to increase that time. So not 1 hour learning and then 3 times practicing, but let's say 1 hour reading about something and then 10 hours, 50 hours practicing it. So that's how you master language. So the more time passes, you should spend more and more time coding and coding. Okay, so let's go back to this example. So I went through this part, which is where they try to access the element of this array that doesn't exist. So it would be somewhere here outside. That's why it broke. And this was at compile time. And then at runtime, here, what they do, they create a const x, and they call the function foo, and they pass the string literal hello to it, and then they just dump it to the underscore variable here, so that we don't get the problem with this not being used. And let's see what the function does. Foo takes one parameter called x, which is of this type, and this is a const slice of U8 type. So here it's interesting now because you have coercion. This is a string literal. In Zig, you don't have string type as type, but the literal exists. And then compiler will under the hood make it an array. But here, when you call the function and you pass the array, you have this coercion because this is not an array. This is constant slice of U8s, not an array of U8s. So Zig will convert the array into const slice. And then the return value, the return type is U8, which is basically the theoretically they wanted to return a specific element, but in this case, again, they are reaching into the element that doesn't exist. So there are 5 elements, so the last index is 4, and they are trying to get the element with index 5 here. So that's, of course, going to break, and then this is a runtime error. And the compiler, you see here, the error is now a bit different. So in comp time, you get these 3 lines to explain the error. It's actually these 2 lines. So this one is just informative. And here it's a bit more. So there is an error stack here. So the chain of events that caused during the runtime. Okay, let's see what you guys say. Mehran asks, what are your thoughts on it? On Zig? Yeah, I love it so far. So it's a very, very interesting language. I mentioned before that I'm a web developer. So most of the time, not most of the time, the entire time that I was hired as an employee was when I worked as an employee of any company, I was hired as a web developer, full stack web developer. So I used Java, Python, JavaScript, and languages like that to work in companies. But as a freelancer, I mostly coded. Yeah, I started also with web, but then I switched to blockchain and things like that. So I'm not a low level. Why I'm saying this? So that you understand, I'm not an expert in low level programming languages. So I never did something in C, for example. Yes, I did learn C when I was studying. I learned C, but I never wrote a single line of code outside of the university. So I never was paid to code in C, which is comparable with Zig, like the level. Low level language. So that's why the lowest level language that I use professionally that I got paid for is Solidity. So for blockchain. So it's very low level as well. And but it's a different thing. It's very specific. So it's meant to programming Ethereum compatible blockchains. So it's a bit different because it's this narrow niche. So it's a very specific thing. And I haven't done anything with C or Zig, but I do have this experience, like let's say with Solidity, playing with lower level languages, but most of my experience is with higher level languages like Python, JavaScript, Java, and so on. So they're a bit higher than Zig. So I still cannot have an idea how actually good Zig is. So I already know what I noticed with my experience, because like I said, I'm not a low-level developer, but from what I know about low-level programming, I already like a lot of things about Zig. So a lot of things, how it manages memory, how it forces you, not forces you, but allows you to take care of the memory in a correct way so that you don't have bugs in like in C. Some other things that are also specific. So how some literally small details, how you can use some operators and how it forces you to think in a specific way. This is like the style, let's say, the style that is integrated in Zig is something that I really like. So I already liked it. So I even forgot, if you watch my previous videos, I literally, when I was reading the documentation and when I figure out something in Zig, how it works, I was like, aha, this is so cool. So there are several things that I really, really love about Zig. And I think it has, so one of them, for example, I'm not a developer, a game developer, but I've seen that Zig has this natural support for C, integration with C. So that's the first thing that's important for gaming. And the second thing is SIMD. So optimizing the code to run on graphic cards. And so this can be also used for AI, not only gaming, but let's say those two industries for sure could benefit a lot with Zig, because it's so fast and safe language to write. And I believe that in the future it will be used for, let's say, in things like Unreal Engine. So now you have C++ there as the main thing, but I believe that they will add support, maybe not to them, maybe not Unreal, but there will be some other language that will leverage the power of Zig, because it is literally perfect for this kind of things. Let me see what you wrote. The question is about that. Sorry, but I asked about course. Read about that. Aha, sorry. Like where's the resources, and also how do you start? So for Zig, if you speak about Zig, you don't have that many resources. So I was recommended here by the guys who are watching. You have how it's called, Ziglinks. Sorry, Ziglinks. So if you Google it up, it should be some. I never touched it because I don't want to do anything out of the stream before I reach the day 30. So once I finish and I reach day 30, I will check this Ziglinks website, which was recommended to me. But outside in that, like I said, you don't have that many resources for Zig. So you have maybe 2 books on Amazon. One is even not ready, so it will come in September. So you cannot even read it now, even if you buy it. You have to wait for it. There is another one. So maybe I will buy also that one after I finish 30 days of Zig coding challenge. And you have maybe some YouTube videos, and that's about it. So you don't have that many resources for Zig. I will create. So my idea is also that as soon as I reach day 30, I will start creating a tutorial, a Zig tutorial. So I will then do a deeper research into Zig, and I will then post video one by one that are smaller. So I will not stream it. So I will just like make a video, I don't know, 10 minutes video for let's say one topic of Zig, strings, let's say, something like that, for example. And I will make a 10-15 video, and I will make this as a series, like a tutorial. So in, let's say, a week or so, I should be publishing the first one. So it will depend on my time, but I will do my best that I do this. Hi, Jorge, how are you? Let me see what you say. No. The SIMD we were talking about with vector is this SIMD stuff with the CPU. Aha, the CPU only, so it's not GPU. Ah, sorry, my bad. Hello, var 2040 Roma. What is Zig? Zig is a low-level language like C, but it's a newer one, so safer. It's designed in a better way than C. Of course, they applied like 40 or more years of experience with C, and they've upgraded the tech. So this is literally like C is made in 70s, right? So if you compare, just take a look at the cars in 70s, how they were working, and what you have now in 2025. And that's the difference also. So more modern approach, more modern language, but C, low level. Okay, let's see what's the next topic here. Cast negative number to unsigned integer. Okay, so at again they will provide both compile time and run time errors. So during the comp time, they have this const value of i32, and they set it to -1. Then they create another constant unsigned this time, which cannot take negative numbers, right? So the type is u32. Well, the size doesn't matter in this case because this is so small. So the size is not a problem here. The problem is that unsigned cannot accept the negative sign. And then they call this built-in function in cast value. So this value is passed, -1, and they just dump it here. But the problem is that here it will crash because this type cannot represent -1. No negative numbers. And let's see how they do it during the runtime. So now in the main function. So you can see that here they always use comp time block instead of main function because they need it to run during the comp time, during the compilation. And here they are calling the main during, like the first thing that you do when code runs after it's compiled is it's going to execute the main function. So this is during the runtime, right? So they create again the value. So the same thing, they create a variable this time, not a constant. So here it was constant because comp time, right? Cannot be a variable. Here they just dumped, so they took the address of the value and they dumped it to not cause the problem, at least for this, that variable is not modified. Then they created a constant. Unsigned is the name of the constant. They try to do the same, u32, and they try to cast this integer, which is negative, into something that cannot be negative. And they will get a similar error. So not the same. Again, this error is a bit shorter during the comp time. And here there will be some chain of events in the runtime that will cause more verbose output to explain the similar error in the runtime. Let me see what you guys wrote, like Rust. So yeah, like a Rust, but Rust is more meant to replace C++. I would say personally, what I think is Rust is something between the level of Rust, is somewhere in between the C and C++. So it covers C++, but it also has some lower level approach. So it's kind of somewhere in between. But if you see what they're doing practically with Rust, they are nowadays replacing C++ code mostly with Rust. So you could say that Rust is a modern version of C++, and Zig is like not a replacement. So you still can use C language, but let's say you can compare it in that way, so that it's a better, more modern version that of a language that is similar to C, that you can use to do whatever you can do in C, but in a safer way. Let's see what Jorge wrote. It's much simpler than Rust by design. But yeah, they target the same space. Zig is not memory safe, but memory management is much simpler in Zig than in C. Yeah. Yeah, so in Zig, compared with Rust, in Zig you don't have this borrowing and ownership concept. So the compiler is like, in Rust is the boss. It doesn't allow you to do anything with the memory that would cause some problems. In Zig, you theoretically can play with memory, but still you are not enforced, but it's simply different. So you do manually deallocate. So in Rust, borrow checker will do that for you. In Zig, you have to do it manually, but compiler will check still what you're doing. So and you have this defer keyword that helps you to write immediately when you take some resource, some memory. The line below it, you can say defer and deallocate the memory, and you don't then think about it anymore. So you will not forget, because as soon as the scope is finished, so like something like a lifetime in Rust. So as soon as the scope is finished, then defer will be triggered, and your memory will be released. So the advantage is that you write it immediately below. You can write that immediately below. So you don't have to. You can still do it later, I believe. So I'm not still expert in Zig by any means. But for what I believe, what I know, what I believe I know, is that you can. You don't have to do it immediately after you take some resource, but you can. That's the point. So you have this mechanism that will allow you to do a memory management manually, but in a nice way, in a correct way that will avoid making some memory leaks and things like that. Let me say what else you wrote, Jorge. For example, if a Zig function uses memory, it states it explicitly. Yeah. Thanks, Jorge, for explanation. Let's go to the next. Illegal behavior. Cast truncates data. Again, first comp time. So they have the Spartan count constant of u16, and they assign 300 to it. Then they have another constant byte, they call it byte, of u8. They then cast integer, they try to. Spartan count, 300, yeah, I was thinking why 300, yeah, this is Sparta. So then of course, because this is u16, and 300 is larger than the maximum value of u8, so 255, right, is the largest u8 possible. So this is too big to fit into that type, and then of course compile error will appear. And the same way, in a similar way, they want to do it here in the runtime. So they have, again, Spartan count, in this case just like it's a variable, they dump it afterwards to avoid the compiler error for this part, that the variable is not mutated. and then they do the same. So they have U16, they try to cast it into U8, and then it will break the code. Okay, then let's see what they just say here. To truncate bits, use truncate. Okay. So this is a built-in that can help you to truncate if you need to. Then the next example is integer overflow. Default operations. The following operators can cause integer overflow. Yeah, of course. So if you add, it can go on the higher side. If you decrease, if you subtract, then on the lower side. Then negation, multiplication for the obvious reasons. Then let's see what example they provide. You have byte, which is a variable, U8, 255, so the largest possible U8, and then they try to increase it by 1. And then, of course, this will break. And here they have the same thing, but during the runtime. Okay. Then let's see what they say next. Standard library met functions. These functions provided by the standard library return possible errors. Let's see just which of them are there. So they are all from STD math. And then we have add, subtract, multiply, division with truncating, division with floor, or floor division, how it's more precise to say, exact division, and what is SHL? I'm not sure what this is. Then let's see what they provide. As an example, they create again U8 type of variable. They call it byte, maximum value here. Then what they want to do, they want to reassign something to it, and what will depend on this will depend on this condition. So they test if when they call this function math.add, if they take in the byte as an input and 1, which I guess, because I haven't used this function before, but I guess this is trying to add 1 to the byte, and then it does this as a U8 operation. So you can say what is the type that you can, the type of the result probably, or however you want to call it, that you want to use. Then they try to see if this is going to return something like true, or if I believe, if I'm not mistaken, the conditions are false, not only if it's false, but if it's null. And I forgot what was the one more thing that can be here causing this to fail in Zig. Then they take that result as, so this is a capture group, so they will take the result and then they will here basically assign it to this byte here if this is true. Else they will capture the error, they will use the capture group, and then this is what they do inside when there is an error. So they will print unable to add 1, and then they will take this error. So this is the built-in error name function, which will take this error and it will give you the human readable name of the error. And it will also return, which means the byte will get this error as the value, because the error is, I believe, because this is a byte. So then this is, if I'm not mistaken, error is like the same type. It has to be the same type, otherwise it will not be able to be assigned here. So this is then the code, I believe. So the byte is U8, so this has to be U8. So it's a code for an error, and that's why they take the error name here. They take the number and get the name to inject it here as a string. And then we have the unable to add 1 here. Overflow is the name of the error, and the byte gets the code of the, okay. And let's see the next thing, built-in overflow functions. These built-ins return a tuple containing whether there was an overflow as a U1. Yeah, this is also one of the things that I love in Zig, that you have these not standard sizes of integers. So this is literally like 1-bit integer. So these built-ins return tuple containing whether there was an overflow as U8, because that's literally what you need to say there was an overflow, and possibly overflowed bits of the operation. Okay, add with overflow, sub with overflow, multiplication, and SHL with overflow. Let's see what they do. Again, they create U8 byte. They assign it the highest value here. Then they have OV constant, which probably stands for overflow. Then they call this built-in method function, add with the overflow. They take the byte, which is already at the highest level possible, value possible for this type. Then they try to add 10 to it with overflow. Then, like we've seen here, they say it returns a tuple containing whether there was an overflow as U1 and the possible overflow bits. So in this case, this will return a tuple which contains, so I don't know if they will return the bits as, they will group them as one array or something like that, or they will separate them, I don't know, but for sure the first thing is this thing. So that's why when they say OV1, I guess that they are taking this overflowed bits. That is the second, so I guess it's either the first bit of the overflow or that group of bits. So let's see what they do, and it will make more sense. So they take OV, the second thing, so index 1, and if it's not 0, then they print overflowed result. So this is it's the result is the first thing. Okay. So then, if I'm not mistaken, there are 3 things. We can check the documentation, it will be easier to see how it looks like. Align, where is it? How it was called? Add with overflow. Why I don't see that one? And they are not. Okay, this is not the definition, doesn't matter. So let's not waste time. I have to open a different page, not this one. This is just referring to itself. Okay, so then else they take that OV, and let's see what happens here. Overflowed result 9. Okay, so because they take 25, they try to add 10. So then the first number, the first value, if you add 1 to 255 would be basically 0, right? Then the second will be 1, and then 2, and then 3. So that's why the result is 9, the overflowed result. Okay, makes sense. Overflowed result, so it triggers here this branch, which means then that the second thing inside of the return in that tuple was not equal to 0. So then I think then the result is actually a number here, not an array. Okay, now it makes more sense. I mean, the second thing in the result, it's a tuple. So the first thing is this U1. The second thing is the result itself. Okay. Wrapping operations. This is cool. This is what Robert used in his version of tic-tac-toe that we went through yesterday. This is familiar for that reason. If you guys haven't watched that video, you can. It's very interesting. So these operations have guaranteed wraparound semantics. Okay, so plus modulus, minus modulus. So this is not actually modulus, it's wrapped around. So I call it modulus because usually you use this operator, %sign operator, as a modulus operator, but in this case it's not modulus at all. So it's a wraparound addition, literally, like this is how you read this operator together, like these two characters together, they make this operator. This is how you call it. So plus % means wraparound addition, minus % means wraparound subtraction, and so on. So negation here. This is, yeah, it can be binary operator and unary operator here. And then finally star % is wraparound multiplication. Okay. And they provide the example. let's see what they do. So they, okay, this is for testing, we don't care. They take the mean integer from the math mean integer. So I believe this is the literal minimum value for the type and the maximum value. So we will see. Then they create a constant x of i32 type, and they set it to the maximum value. So I guess that this max int under the hood can see because you pass the type as the argument. So I guess then that this max int, if you say u8, it will tell you 255 will be the result. If you say, I don't know, u16, it will be 65,000, blah blah. So I guess this is what happens. Then they create the mean val, and then what they do, they take the x, which already has the maximum value for the type, so 32 ones in binary, and then they add 1, which will then, but with this, how it's called, wraparound addition. So they do the wraparound addition, which basically should, if you have 1, 1, 1, 1, 1, 32 times, you add 1 to it, it will reset to the smallest value of the type, and that will be, do they print it out? No, they don't. So I can run this code and we will see. And then let's see what they do next. That we can know, so from this how they test, because the test passed, so that this will match. So the minimum value that you get from here is the actual minimum value for that type, because you call this function, and that will be like minus whatever, like, so I cannot even say what that number is. Like, it's not billion, it's like quintillions or something like that, negative for i32. So the largest, the smallest i32 value possible in any programming language is the same here. And then max value is kind of the opposite. They set it to the minimum value. Sorry, they take the minimum value of the type and they do the wrapped subtraction, and then they check if it's the largest here. So in this case, it's, let's print it. So I'm just like curious to see the numbers. I know it's a huge number, but let's just let's do it in this way. I will just take these two, and then I will just take, but I'll change the code a bit. So here in our main, we can let it do all these things, but I will just print here. So the first one will be the mean val, and I will just take it here. And in a similar way, I will print the max val here, and I will just uncomment this twice, we don't care, and I will just take the max here. This is just because I'm curious to see what is the 32-bit largest value and smallest value. Yeah, so this is, how come this is the smallest? This is not so big for 32 bits. I was expecting more. So this is 2 billions. Yeah, it's not that. Yeah. So I think in my mind I was thinking 64. So this is not that big, not that small, if you will. So it's 2 billions 147 millions, and so yeah. So we have our answer. What we have as the smallest and the largest. Okay, let's see the next one. Exact left shift overflow. What they do here, they create a constant x. Aha, this is shift left then. Okay, SHL means shift left exact. Okay, makes sense. So what they do, they first take the binary literal 01010101, right? So this is like 1 byte of information. Then they treat it as U8. Okay, they convert it to U8, coerce it basically, because literals, even though this is in binary form, I believe this is still comp time int in Zig by default. So any numerical integer literal will be comp time int. So they cast it to U8 first. So then once they have this number as U8, so whatever it is in a decimal form, doesn't matter. They shift it left 2 places. So that would basically add 2 zeros here, right? And then the point is that this part will overflow. So you will lose these most left bits of data. And that's what they have here as the illegal behavior. Operation caused overflow, shift left, blah, blah, okay? And then they do the same with in the runtime. So literally the same number. They convert it to U8. Here they dump it, the address of X. Then they again try to make a constant Y, and they want to shift left this number for 2 positions, so 2 bits to the left. And again, you have the error that is overflow. Exact right shift overflow. So this is the same, but they shift right. So shift right SHR exact. And they do the same thing, like we don't have to spend time on this. So the same thing, literally, they just make you a U8 first out of it, then they try to shift it to the right side. So then here you will have 2 bits more on the left, but these 2 will go out, and that's the problem. And here the same time, but in the runtime. Okay, then division by 0. Of course, illegal behavior in most of the languages. Constant A, 1, constant B, put iterate 0. Then you try to divide 1 by 0. Of course, that is not allowed. They dump this, so it will already break here. So, but this is that you don't have secondary errors in compiler. And then, of course, we get division by 0 error. And the same thing in the compile time. The only thing that is different is that now they are creating 2 variables here. They dump them both, so they put them in a tuple, the addresses of these 2 variables, and dump them. So if you're guys seeing a lot of this and you're confused in Zig, if you don't mutate the variable, you'll get an error. So that's why they always have to change it, and this is considered a mutation. So if you use the operator address of, it's considered a mutation. So they are just now doing this in one line, so they don't have to. They can do what they did here in one line. They can say 1 times for the A, then second line for the B, but this is just to do it in one line. So they create anonymous struct. So this is anonymous struct, which is also called tuple in Zig. So they just put these 2 address. So this is address of operator, which is good enough so that Zig will not complain that you're not mutating a variable. So this fixes that, and you don't dump it into this underscore special variable. I forgot how it's called, but it's a special kind of variable that can be used if you don't intend to do anything with these. So this is just to satisfy the compiler that doesn't complain about this part, that you're not mutating variable and that you're not, basically that part. And then here you are, they are creating a const C. They are trying to, again, do the division so 1 by 0 division, which will of course cause an error. Let me see what you guys wrote. Andre, hello Andre, how are you? So Andre explains this underscore trick is used to silence compile error about variable not being const. Yeah. Okay, so yeah, so you have basically, if you don't mutate, it should be const. But if you don't use the const, you will also get another. So you have these 2 things that are always happening in Zig if you are defining something and then you are not respecting the rules of. So const has to be at least used. So that's why they are using this part. And this part here where it was is about mutating. So this is because you still have to do both technically. Okay. So remainder division by 0. So very similar situation. They are just using the different operator. So here they are dividing, and here they are using the modulus, so the remainder, and the same thing. So because this is under the hood also it has to divide and then see what is remaining after the division. And if it cannot even divide, the first step fails because 0 here. So again, very similar. So I'll not spend time explaining what's happening and going through it. I mean, I'm explaining to myself and thinking out loud. Then this is also the runtime version of it, similar like with division. Then exact division remainder. Okay, so very similar, but in this case, they're not using the operator. They're using this div exact built-in function, which has the same problem. So, no, actually, it's a different now. It's not 0. Sorry, wait, give me a second to see what they do here. So they have 10 and 3, U32s. They want to do the exact division. And then they say, produce remainder. Aha, yeah. So this is different because you have the remainder. And you are asking explicitly here for the exact division, so without remainder. Okay, yeah, a bit different situation. And here the same thing, but in the runtime. Okay, then attempt to unwrap null. Let's see what they do. So they create a constant. They call it optional number, and this is optional operator, which will make an optional i32 type. And they set it to null. So this is basically making this optional because it can also happen that it is null, and that's literally what they do here. They are setting this to null rather than to i32 value. Then const number, they take the, so I forgot how to say what is happening here, but basically they're kind of like unwrapping. I don't know if it's the correct term, but they're trying to take the value out of this optional number. And then, yeah, it's called unwrapping. So then you have the error, unable to unwrap null. So the point with optionals is that you potentially can have a null, but if you don't have null, you can take the value out and then unwrap it. So this process is called unwrapping, but you cannot unwrap null because you're technically saying, I want to have i32 out of null, which is not possible. And at runtime, they do the similar thing. So they just have in the runtime, they are doing it a bit different way here, but this part is the same pretty much, except this was a const, here it's a variable, so that's why they have to do this, and then like before. Then the next thing, one way to avoid this crash is to test for null instead of assuming no-null, which with the if expression. Okay, let's see what they... now they're explaining actually how to avoid this crash. So let's see what they do. So this part is the same. Then they test the optional number. They create this capture group here. They will take the number. So if this unwraps successfully, so they will then print here the number. And here in the else, if you're in this branch, it means that this was what it is here in this case. It's null. So it will trigger the else. So optional literally means like it can be either null or in this case i32. So it doesn't have to be i32 optional, but in this case it can be either null or some number of this type. And in this case, because we set it here to null, it will trigger the else, because if null is false. Okay. Then next thing, attempt to unwrap error. Okay. Then they have the comp time code block here, in which they create a constant number, and they make it by calling this function that they define here. And then they take this result from whatever the function returns, and then they try, because it can be an error, right? They catch the error and then catch the unreachable. So here, let's see what the function itself does. Get number of fail. So this is a union now. So it's a union, which can be i32 or null, void, how you say here, not null, but void, I believe is the correct term. So then they return the error, unable to return number. Okay, and that error will be caught here. And let's see what they do. Yes, because they, so if I'm not mistaken, because they are returning an error here explicitly, when you call a function here, this will be an error that will trigger this catch expression here. And then unreachable is the code that you should never reach. So that's why, if I'm not mistaken, we have an error. And the similar thing happens here, but in the runtime. So the function is literally the same. And here they do the same first line. So yeah, it's very, very similar. Okay. Okay, then the next example for the same thing. Only way to avoid this crash is to test for an error instead of assuming a successful result with the if expression. So let's see how they do that. Const result. So first they store the result here in the result. So the type will be inferred. They're not specifically saying what is the type. Then if result. So if it's something that is not falsy, or how to say, it will then be captured by this capture group, and you just print it as a number. So then it will be, what is the type? I forgot here, i32. Yeah, it will be i32 number. But otherwise, it will catch this error. It will capture a group will be triggered, and they just call it error in this case. So you can give it a name whatever you want. It's like any other variable. And then they got an error. They print got an error, and then they take the error name built in and they pass this error. Okay. Then let's see the next thing. And then of course they here say got error and the name of the error. Then invalid error code at comp time. Let's see what they do. They create a constant error. They call it error, and they take the error dot an error. So this is, I believe, built in, that you don't have to import explicitly. Then here they create a constant number. They call the built-in function integer from error. They pass in this error code, or they are just like generically saying, so I'm not sure what they are doing here, but anyways, the point is that it will be some error code, and then they try to add +10 to it, and then they say const invalid error is going to be error from integer. So now they want to take this number. So let's say this is a legit error. Let's say 100 is the code, doesn't matter. Then they make this 110, and they try to see what is the error with this error code, and they make sure that this error code doesn't exist. So error integer value 11 represents no error. So there is no such error that has the code 11 in this case. So then we know this an error is 1. Okay, from here. Okay, at runtime, they do the similar thing. This is the same. Now they do +500 instead of +10. Then they dump this. Okay. The same thing here, and then they print it, and they will get, where is it? I'm blind. Invalid error code. Yeah, I don't see the error code. So value, where is it? I'm blind. Value. I don't see that anywhere. Because it's in runtime. Okay. Then it breaks before it prints, obviously. Okay. That's why I don't see it. Then invalid enum cast. At comp time, they create an enum. Let me see what you guys wrote. Hi Dev, how are you? Welcome once again. So they have this enum. They call it full with these 3 fields. So then they do the comp time block code. They set a const a to the unsigned integer of 2 bits to 3. Then they have const b they call it foo. So not the call it, they use the type foo. So the name is b, the type is foo, and then they try to take the enum from integer a. And what is the problem here? So the enum starts from 0, so this would be 0, 1, and 2. So there is no value 3 in this enumeration, so this will be an invalid thing to do. So you cannot set this enum to 3 because there are only 3 elements, and the last one has the value 2. And then they say something like that here. Has no tag with value 3. Yeah, so that's basically what I just said in different words. Then at runtime, they do the same thing, I guess. They create the same enum. So they set the a to 3. They want to make an enum they call b of this type foo from 3, but you cannot. So this is not this a. So this is the variable is not related to that. So it's a different variable here with the name a, which has the value 3. So they're trying to make an enum with this to set the value, to select the value, how it's proper to say, with the value of 3 of this enum, and that doesn't exist like before. Let's see what you write goes. Dev asked Andrei, what silence compile? What is the silence compile? Then let's see what's the next thing here. Invalid error set cast. So they create one set with A, B, and then another set with A, C fields. Then during the comp time, they want to do error cast set1.b into set2. And you cannot do that because the error sets, if I'm remembering correctly, if you cast one set to another, one error set to another, you can cast a smaller to the larger. So this one on the left has to have everything. So if you're casting into a set 2, it has to have everything from this one if you want to cast it into with this value. So that will break. And in the same way here, they are trying to do the same thing in the runtime. Okay, then incorrect pointer alignment. Let's see what they do here. And by the way, there are a lot of these things. Let me just see where we're at. So I don't want to make this video longer than it has to be. Where is the illegal behavior? Here. So division by 0, invalid error code, invalid cast, set cast. Okay, so it's not that far from the end. So I will finish it today. I don't want to push it for tomorrow if I can finish. So it's not that far. Okay, incorrect correct pointer alignment. Compile time. Let's see what they do. They create a pointer PTR constant. What they do, what they assign it to. So first of all, what the type is. I don't even know how to read this. So this is aligned pointer of 532. I don't know how to pronounce, but this is the idea, that it's a pointer that is aligned with this type, of this type. And then they are calling the built-in. They say pointer from integer. So this is number 1 in binary, decimal, hexadecimal, the same. Then they want to create a pointer from this memory address. So this basically represents, because it's a pointer memory address. So then they call it PTR here. Then they create another constant called align. And now they are aligning it with a different value here. So here it was 1, here it was 4. And then they want to do align cast from this pointer to this one. So the type is the same, but this alignment is not the same. And that will be the error, right? So pointer address 0x1 is not aligned to 4 bytes. Yes, because you have only one, I believe. one byte here explicitly said, if I'm not mistaken. Then at runtime, what they do, they have here, the first thing they do is they take this array, which has 2 bytes. This is the first one, this is the second one. So the array type is U32. Okay. And it's, I believe this is going to be determined in the comp time if they put underscore. So U32s. So this is actually 2 bytes, right? So it's 8. So this is hexadecimal. It's not a binary. It's not 111. It's not, because it's not 0B. It's 0x, which means these 4 digits are hexadecimal. 1 byte. This is another one. So it's 16, right? So why then 32? So okay, they can make it U32, I guess, if they wanted. Let's see what they do here. Mem slice as bytes. They slice the array from the first element until the end. Then if foo bytes not equal, so let's see what foo does then first to understand what is this. So they pass the bytes array into the foo function, and they see if the result is not matching this, they will return the error wrong. And then let's see what the foo does. So the foo will receive, here in this case, these bytes. The return type is U32. Then const slice 4 equals bytes from 1 to 5. Okay. So you have 4 align. I believe this is not going to work because it's, I know it's 5. The last one is 4, but then it will be 3, right, bytes. So let's see. Constant slice, mem byte slice is okay, let's see first what happens here, because I have to read it from inside out. So first they align cast slice 4. Slice 4 is this one. This is, sorry, this is a different one. So they're not using the input. I mean, yes, they're using the input, but they're creating a different const here. That's what I wanted to say. So here they are taking that constant that they create here. They call the built-in align cast, and then they are taking, let me just try to decipher what is happening here. So they have this as, which starts here and I believe ends here. So they are taking this as the thing that they want to cast, and they want to cast it into this thing here, if I'm not mistaken. So then they call these bytes a slice to make it a slice of U32s. Yeah, very hard to follow what happens here. And then let's see what's the, so the error is here when they are trying to do this, and what they say, incorrect alignment. Yeah, alignment. Why? Because here it's aligned 4, but yet here this is where they made this problem with the alignment, because they take only the 3 bytes, if I'm not mistaken. Let's see. Okay, let me see what you guys wrote. Jorge says, he responded to the dev. He means that you can use underscore equals foo to explicitly communicate to the compiler your intent is not to use foo's value, as opposed to you just forgetting to do it. Yeah, basically, like, I know what I'm doing. Okay. Thanks, Jorge, for explaining. Let's see what is the next thing. Wrong union field access. So here they have the variable called f. They say it's of foo type, which is this anonymous struct, which has they set the int field to 42. Then, no, sorry, it's not here. I'm not looking. So here is where first they create the scene union. So I thought they are just like creating like a pseudo code that they are, but they're actually using the concrete code here. So they first create the union, which has two fields. So float and integer, float f32. So this is just the name. So how they call it, float, it can be x, y, z, doesn't matter. This is the type of that field. And in the same way, this is the type. So f32 for this field, and then u32 for integer. So then they say they want to create this f, which is set to, so I believe the correct term is activated. So they activate the integer part of the union, and they set 42 to it. And then they're trying to do this, and then they will get this error, access of union field float while integer is active. Yeah, so activated was the correct term. So they haven't activated yet the union for this type. Okay, at runtime, so let's see what they do. So the same union type here, the same thing they try to do here, but because now this is, so here the variable, I'm just like trying to figure out why they're not using this there. So they have to try, yeah, because this is kind of like compiler sees that you're trying to mutate, so that's why this is not going to need this part here. And in this case, because you're not trying to mutate directly, I believe that's why it's going to complain if you don't have this. They oh no, they're actually using it here, so it's not, they're not dumping it, it's just they calling the function bar, so different reason. Then bar is the pointer to foo, okay, doesn't return anything, and here they try to do the same. So they just do it in a function call instead of what we had before in the comp time, and the similar error. They will say it's not activated. Yeah, it's not active. Okay. What they say, this safety is not available for extern or packed unions. To change the active field. So I never tried packed unions before. I just read about them in the docs a few days ago. But when I played with unions here, I did the regular ones that are not packed. And I didn't use the external ones either. But let's see what they say. To change the active field of a union, assign the entire union like this. Let's see what they do. So the same union, then they create a variable, they activate integer, they set it to 42, they call bar, so the same thing what they did here. So this part is the same, but the function will now do the different thing, right? So, and this is now how they activate. So this is the proper, so this is the difference here. They just try to say f.float equals, and they just want to assign the number, which is not correct because it's activated for the integer, not for the float. And here they are actually activating the float in this way. And then they are, so if I'm not mistaken, what actually happens here in the background, this is anonymous instance of this union, which, so you technically don't activate the original one, but you are creating a new instance of a union, which is now activated for the float, and then you reassign that for this variable here. So if I'm not mistaken, maybe I'm mistaken, to change the active field of a union when a meaningful value for the field is not known, use undefined. Let's see what they want to do. The same. Now this is different a bit. So in the main, they first do, okay, this is the same, but then they say f equals. So basically they do the same thing, the regular thing they did here. They are just doing it here in the main instead of the bar function. So first they set float to undefined. Then they call the bar function with the address of f. And then they print float to see what it is there. And then they, because they called the bar function with the address of f. And then of course here it's the pointer to the foo union. Then they take that reference and then the address, or however you want to say. So this f, variable, and they say f.float to update it to 12.34, and then this is what you're actually getting here when you print. So this is a scientific notation. So 1 times 234 times 1.234 times 10 to the power of 1. So 10 to the power of 1 is 1. So basically 1.234 times 10, which is 12.34 exactly. Okay, out of bounds float to integer cast. This happens when casting a float to an integer where the float has a value outside of the integer's type's range. Aha, this is interesting. So the float, they give this as an example. And from the previous, like 20-30 minutes ago, playing that we did here, we know this is the highest integer 32 type value. So this type here cannot have 4 billion and something. That number is simply too big. So the largest one is 2 billion and 147 million. So here you have a float. So it's not the problem that you have decimal point because you don't. So this is a round number. But the problem is here is that you simply have too big of a number to try and make integer from float by calling this built-in function. And then of course you have float value cannot be stored in this type because it's too small. And the same thing at runtime. So what is the difference? This part is the same. So they, I mean, not the same because here they use variable, here they use const, but the value and everything is the same. Then they take this so that they mutate the float. The compiler does a complaint, and then they cast it here to dump it to underscore. So then, because if they were just to do this without this part, then it would complain that it's not mutated. The float is not mutated. So this is technically mutating, but because you don't need to do anything with this mutation, you just dump it. And in this case, they again do the same thing like here before. So literally the same part here. And now they dump the const because they don't want the secondary compiler error. But the primary thing is that the same like before, you cannot cast. This is too big for integer. Pointer cast invalid null. Let's see that one. This happens when casting a pointer with the address 0 to pointer, which may not have the address 0. For example, see pointers, optional pointers, and allow 0 pointers. Allow address 0, but normal pointers, like these are not normal. Crazy pointers. Do not. Okay. So what they do here, they create the constant. Call it OPT PTR, which is an optional pointer to the i32 type. They set it to null. Then they create a pointer. They call it PTR, which is the pointer to i32 type. And then they try to cast by calling this PTR cast built-in method. So they try to cast this one, which is a null pointer, to what they say it's a normal pointer, right? So then it will fail and it will say null pointer casted to type i32. So this is a normal pointer to i32, which cannot be null. And the same thing in the runtime. So the only thing is, again, difference is here. So the variable instead of const, but they technically do the same thing. So just dumping and doing these regular things. Okay, we reached the end of it. So cool. I thought I'm not going to finish this today. I thought it's simply too many things to cover, but literally we finished just in time so that this stream doesn't get too long. Let me see what you guys wrote. Not normal as in insane. Can reference memory only the OS has access to. Yeah. Insane pointers can reference memory only the OS has read-write access to. Okay. Read-write. Thanks for explaining. And let's see what's the plan for tomorrow. So first I will do the summary stream. So I will do some, like I mentioned before, I'll probably start a 4-in-line mini project so that I practice these things that I learned in the last 5+ days. And I will try to use the Robert's tic-tac-toe code as a reference so that I use all these things that are mentioned there just to practice. Then after that special stream, special edition, I will go with day 26. And now let's see what is going to be the topic for tomorrow, because I literally am running out of topics because I covered most of them. So I did covered compile variables, this all I spoke. Zig build system I haven't touched yet because I haven't installed Zig locally yet, but it looks like I might have to do it tomorrow. I will see, because no other topics here. Aha, WebAssembly. So yeah, maybe I'll do WebAssembly tomorrow. Targets we did, style guide we did, source encoding. Yeah, literally only thing that is left is WebAssembly, C, and the build part of the docs. Everything else, let me double check from the beginning, just in case that I missed something. And I didn't do tests, I believe. Maybe I will do actually tests tomorrow because they are general. So they are using them all around the docs, and I haven't paid attention to what they're doing. So I will maybe do this. Then, yeah, maybe this is better than WebAssembly, because it's WebAssembly and C are more specific targets. So C for the interoperability, and WebAssembly for a specific target, actually. Build is generic, but I have to install Zig first. And then this is a general thing that is useful, no matter if you use the C or integration, or if you are targeting WebAssembly. So this is the most generic, more general topic. So I guess I'm going to do tests tomorrow. I don't know how large they are. Let's see. Detect here. Detecting test. Yeah, so this is something that is for sure feasible tomorrow, not a big topic. Then let's see, variables, integers, floats, operators, done. Arrays, vectors, pointers, slices, struct, enum, union, opaque. Opaque, I think I haven't touched. Or if I did, I forgot. So I will do then, maybe tomorrow I will do tests and opaque. Blocks, I did, switch did, while for, if all, done. Defer, unreachable. We went through them, I believe, at one point in the other. So I don't remember if I explicitly went and done them, or we just like jumped, but we touched them. Functions, errors, optionals, casting, all done. 0-bit type, result, location, semantics, usernames. But yeah, literally there is nothing else left. Okay, so then for tomorrow, the plan is first the special edition coding practice, then tests plus the opaque part. Let me see what you guys wrote. And let me go to the outro screen. Don't need the docs anymore. Let's see what Jorge wrote. This section really makes clear the fact that I know compiler is the whole point of Zig. Thank you. Think you'll need to install Zig tomorrow or Friday. Yeah, I'm avoiding, but I cannot hide any longer. So I have something like internal goal that I don't install it before 30 days expire, but I'm running out of options really, so I don't have. If I just stick to the docs, this literally means I will have to. I'm out of topics, so only 5 more days and less than 5 topics that are related to something that I do without installing, Yep. Okay, thanks guys for being here today, and see you tomorrow with these 2 streams. Have a nice one. Bye-bye.